Hello friends, welcome back to the lecture series on linear differential equation. So far we have discussed the method of solving to find general solution of linear differential equation with constant coefficients. To find complementary function, we need to observe auxiliary equation, find out the roots, and we form the solution for complementary function with respect to nature of root. To find particular integral, there were three methods of solvings. First one is general method, second one is shortcut method, and third one is variation of parameters method. So there are some questions from students. So how to identify proper method of solving? In exam, if we apply any other method, it may waste our time. So before solving, by just observing how to decide the proper method of solving. So let's take some examples to discuss. Remember one thing while solving examples on linear differential equation, here f of x on the right hand side in the general form of differential equation, which is phi of t into y equal to f of x. So this f of x will play important role for your method of solving. So for example, if we consider this one, here f of x is combination of two functions. First one is exponential, second one is algebraic. So you can consider we have three different options. First one, we can consider e raised to ax into v because there is one exponential function, and since there is no condition on this v, it can be any function of x, so we can consider v is equal to 1 upon x cube. So this is our first choice. Second one is, if you think this is not in standard form, so we can consider, since degree of auxiliary equation is 2, since f of x is not in standard form, so if it is not in standard form, so we have standard forms e raised to ax, trigonometric, sin ax or cos ax, or hyperbolic, or algebraic, or product of two functions in form of e raised to ax into v, or x into v, or x raised to m into cos ax or sin ax. So these are some standard forms. If your f of x is one of this, then we apply shortcut method formula, and if it is not in standard form, then we have two options. First one, whether to apply general method or variation of parameters method. Variation of parameters method is applicable if and only degree of auxiliary equation is 2. So we have second option, apply variation of parameters method. Now at the time of exam, which method of solving will be beneficial, which will use less amount of time to solve that problem, we have to opt. Same is the case with if we consider second problem. In this case, here f of x is product of hyperbolic function as well as trigonometric function. So product of two function is given in the shortcut method formula, e raised to ax into v, x into v, or x raised to m into trigonometric function. So there is no exponential function here, so directly we cannot apply this or this. Since there is no algebraic function before the trigonometric function, so this cannot be applied. Since degree of again auxiliary equation is 2, so we have first method. The possible method of solving is variation of parameters method, or we can use substitution for hyperbolic function. So there is relation between hyperbolic function and exponential function, so we can convert it in terms of e raised to ax into v, or you can use exponential relation between trigonometric function and exponential function. So it is up to you. So we have two again method of solvings for this problem. Here f of x is in the form of x into v. So here we can use shortcut method formula x into v, provided that whenever we operate auxiliary equation on this v, it must not be case of failure. So we have to test the condition and then we go for shortcut method formula x into v. Again, since degree of auxiliary equation is 2, there is possible chance for applying variation of parameters method. So in exam we may find examples. Just solve these differential equation. Specific method of solving is not specified, then we can go for general method, shortcut method, or variation of parameters method. But in some cases Your question will be solve following differential equation by using variation of parameters method. Then we have to use variation of parameters method. Now, the fourth one is little trickier because here f of x is product of three functions. One is algebraic, second one is exponential, and third one is trigonometric. So we have two choices, or we can have third choice as well. Third choice is variation of parameters method, again because degree of differential equation is 2. What about this? Here we can apply x into v shortcut method formula. This is our v. Or we can apply e raised to ax into v. If we take this exponential function aside and x into sine 2x is v. So we have to select the proper method of solving which will utilize less time. So this is the rough information about how to solve these examples. Let's check the solution. So we consider example number 1. So it is d square plus 6d plus 9y is equal to e raised to minus 3x upon x cube. So to solve this problem, first we consider the auxiliary equation. It is d square plus 6d plus 9 equal to 0. So this will imply our roots are, so it is minus 3 as well as minus 3, since it is square of d plus 3 bracket square. So we have real repeated roots, therefore complementary function will be, so since this root is repeated 2 times, we have to take linear combination of 2 arbitrary constants in increasing powers of x into the exponential function e raised to minus 3x, where minus 3 is the root. We denote this by equation number 1. Now here f of x is e raised to minus 3x upon x cube. If we go for the shortcut method, so we consider this as e raised to minus 3x into 1 upon x cube. So it is in the form of e raised to ax into v. This will imply value of a is equal to minus 3. And since our shortcut method formula is, if we operate auxiliary equation on e raised to ax into v, this is for our understanding. It is not required to mention this formula in exam. So formula is, we take exponential function outside, we replace d by d plus a in the auxiliary equation and operate it on v. So therefore, for phi of d, that is d plus 3 bracket square, if you replace d by d plus a, where a is equal to minus 3. So if we replace d by d minus 3, we get, so it is d minus 3 plus 3 bracket square. This is nothing but d square only. Fine. Therefore, our required particular integral will be, we take that exponential function outside, we use this formula 1 upon phi of d minus 3, and it is to be operated on that algebraic function, that is 1 upon x. So we can simplify it now, e raised to minus 3x into 1 upon d square into x raised to minus 3. 1 upon d represents integration with respect to x, and 1 upon d square represents double integration of x raised to minus 3. So we simplify. So if we operate 1 upon d on x raised to minus 3, so that value will be x raised to minus 2 upon minus 2. So it is equal to minus e raised to minus 3x upon 2 outside, and this integration will be x raised to minus 1 upon minus 1. Again, if we simplify this, so the required answer will be, so it is equal to e raised to minus 3x upon 2 times x. This will be the required particular integral. Now we denote it by equation number 2. Therefore, from equation 1 and 2, so from 1 and 2, required general solution is complementary function plus particular integral. Our complementary function was c1 plus c2x into e raised to minus 3x plus particular integral is e raised to minus 3x upon 2 times x. So this is our required general solution. So this is answer. So if there is another case, we can apply variation of parameters method as well. So for applying variation of parameters method, so we go for filter. Second case. For variation of parameters method, since complementary function was c1 plus c2x into e raised to minus 3x, we can consider y1 is coefficient of c1, that is e raised to minus 3x, y2 is equal to x into e raised to minus 3x. So this is your step 1. In step 2, so this we call it as our step 1. Step 2 is evaluate value for Wronskian, which is nothing but y1, y1 dash, y2, y2 dash, evaluate y1, y2, y1 dash, y2 dash, and find value for w. Then step 3 is find value for u by using formula integration minus y2 into f of x upon w. Take this integration with respect to x, as well as v is equal to integration y1 f of x upon w with respect to x. After calculating u and v, in step 4, apply variation of parameters method, and particular integral will be u into y1 plus v into y2. Substitute values for u and v calculated from step 3. We get particular integral. And in step 5, required general solution will be complementary function plus particular integral. And then verify your particular integral obtained by shortcut method and variation of parameters method will be same. So I hope you will solve it by variation of parameters method. Now we move to the next problem, that is d square y by dx square minus y equal to cos x into cos hyperbolic x. So here we consider f of x is equal to, we first identify the function. We go for shortcut method formula here. Again, we can apply variation of parameters method as well. So first, for cos hyperbolic x into cos x, we use a relation between hyperbolic function and exponential function. So since cos hyperbolic x, go for the standard one. Cos hyperbolic ax is equal to e raised to ax plus e raised to minus ax upon 2. This is relation between hyperbolic function and exponential function. So we use this formula here. So we get e raised to x plus e raised to minus x upon 2 into cos x. If we take 1 upon 2 outside, so we have product of exponential function with trigonometric function plus e raised to minus x into cos x. For applying shortcut method formula while calculating particular integral, we can use e raised to ax into v formula 2 times. So this will be easier to simplify. So since our formula is decided, we go for here value for phi of d is equal So we get back to the differential equation. It is d square y by dx square minus y. That is d square minus 1 equal to 0. So this implies our roots are d is equal to plus or minus 1. These are real distinct roots. Therefore, required complementary function will be c1 e raised to x plus c2 e raised to minus x. We denote it by equation number 1. For shortcut method formula, as phi of d is equal to d square minus 1. So we have to replace d by d plus a, since a is equal to plus 1. So it is equal to d plus 1 bracket square minus 1. So this value is nothing but d square plus 2 times d plus 1 minus 1, which is nothing but d square plus 2d only. So this is for the first function, e raised to x into cos x. Since here value for a is equal to 1, we replace d by d plus 1. And for the second function, here value for a is equal to minus 1. Then we check the value for phi of d minus 1, as we replaced d by d minus 1. So it is equal to d minus 1 square plus 1. So expansion will be d square minus 2 times d plus 1. Straight here, as our auxiliary equation is d square minus 1. D is replaced by d minus 1. So after simplifying, we get d square minus 2 times d. Now we are ready for calculating particular integral. As formula for particular integral is, we have to operate auxiliary equation on f of x. And our f of x is, take one more step, 1 upon 2 times e raised to x into cos x plus 1 upon 2 times e raised to minus x into cos x. So we operate auxiliary equation on each function. So overall we can take 1 upon 2 outside and we apply that auxiliary equation phi of t on e raised to x into cos x plus 1 upon phi of t on e raised to minus x into cos x. Now we simplify each term at a time. So since our formula is, since shortcut method formula for phi of t into e raised to ax to b is equal to, we take exponential function outside, we replace d by d plus a and operate it on second function b. We use this formula for this bracket as well as for this bracket. Otherwise, you can call this as yp1 and yp2 and simplify these two terms independently. So to save up time, we go for the calculations in a single step. Therefore, particular integral now reduces to 1 upon 2 as it is. We take exponential function outside. We replace d by d plus 1 and operate it on cos x. In second term, we take e raised to minus x outside and we replace d by d minus 1 and operate it on trigonometric function cos x. So this is equal to, since we have calculated those values before, so e raised to x into, this value is d square plus 2 times d into cos x plus e raised to minus x into 1 upon d square minus 2d into cos x. So again, since for trigonometric function, shortcut method formula is, replace d square in the auxiliary equation by minus a square. Here value for a is equal to 1. So we replace d square by minus a square, that is nothing but minus 1, and same case is applicable for the second bracket as well. So we have to replace d square by minus 1. So we get back to the solution by applying shortcut method formula 1 upon 2 as it is, e raised to x into 1 upon this 2d minus 1 into cos x plus e raised to minus x into 1 upon minus 2d minus 1 into cos x. So here, if we take this minus sign outside, so it is equal to, so 1 upon 2 e raised to x into 1 upon 2d minus 1. Since there is no d square term, we have to rationalize this. So we multiply numerator and denominator by the conjugate. So that is number 2d plus 1 is multiplied to numerator as well as denominator. Then we apply the trigonometric function on it. So this is just the simplification. Now if we take that minus sign outside, e raised to minus x into, so it is 2d plus 1. Since there is no d square term, we use method of rationalization. So we multiply numerator and denominator by the conjugate of 2d plus 1, that is 2d minus 1. Then we operate it on this trigonometric function. So if we simplify this, 1 upon 2 times e raised to x into, take the numerator term side and denominator term will be 1 upon 4 times d square minus 1 into cos x. Same is the case with minus e raised to minus x into this 2d 2 times d minus 1 into 1 upon 4 times d square minus 1 into cos x. So for both the brackets we use same formula, we replace d square by minus 1. So that will be minus 4 minus 1, that is minus 5. So this value will be minus 1 upon 5. This value will be minus 1 upon 5. This value is again minus 1 upon 5. So we can take that minus 1 upon 5 outside. So this will be minus 1 upon 10 into e raised to x. This will be 2 times d plus 1 into the same trigonometric function as it is, this minus sign, e raised to minus x into 2d minus 1 2d minus 1 into cos x. Now we take this multiplication, so we operate 2d minus 1 on the trigonometric functions. So minus 1 upon 10 into e raised to x. So derivative of cos x is minus sin x plus 1 into cos x. For the second one, minus e raised to minus x into minus 2 times sin x minus cos x. So again we can take this minus sign outside. So it is equal to minus 1 upon 10 minus 2 times e raised to x into sin x plus e raised to x into cos x plus 2 times e raised to minus x into sin x plus e raised to minus x into cos x. So if we rewrite it properly as minus 1 upon 10 into 2 times e raised to x. If we take this minus sign inside, that will be a little interesting. So this will be e raised to x minus e raised to minus x into sin x. Okay. If we take this minus sign outside, so this will be e raised to x minus e raised to minus x into cos x. If we rearrange the terms here, 5 and 2 here, so we can rewrite it as 1 upon 5 times 2. This value is nothing but sine hyperbolic x into sin x. We take this minus sign inside, both terms will be negative, so this negative sign will be present. Then minus cos hyperbolic x into cos x. So this is the required particular integral. We denote it by 2. So from 1 and 2, the required general solution will be complementary function plus particular integral. So please substitute these values here for yc as well as yp to get the required general solution. So since we have taken this negative sign here, so both terms will be negative. So we take minus sign as it is, and this is nothing but cos hyperbolic x. And this is your shortcut formula for sin hyperbolic x. Now we go for the third problem. Here f of x is product of one algebraic and one trigonometric function. We can consider it is in the form of x into v, and shortcut method formula is 1 upon phi of d into x into v is x minus derivative of auxiliary equation with respect to d upon auxiliary equation into 1 upon phi of d into v. And the most important condition is value of this part must not be obtained from case of failure. So we check whether it is case of failure or not. So for that thing, we consider auxiliary equation. So it is equal to d square plus 3 times d plus 2 equal to 0. And roots of this polynomial are, so it is equal to d plus 2 and d plus 1. That is, d is equal to minus 2 and minus 1. These are real distinct roots. So by shortcut method formula, if we replace d square by minus 4, so this is not the case of failure. So this value is obtained without any case of failure. So we are through. We can apply shortcut method formula. Otherwise, we can apply variation of parameters method as well. So we consider complementary function as c1 e raised to minus 2x plus c2 e raised to minus x. We denote it by equation number 1. Now we go for particular integral. Instead of calculating particular integral, we evaluate the value 1 upon phi of d into v. That is 1 upon d square plus 3d plus 2 into sine 2x. So it will be easier to substitute that value in the standard formula directly. So by shortcut method formula, for trigonometric function, we replace d square by minus a square. So value for a is 2. So minus a square will be minus 4. So we replace d square by minus 4 plus 3 times d plus 2 into sine 2x. So it is equal to 1 upon 3d minus 2 into sine 2x. So for trigonometric function, for applying shortcut method formula, we must find d square here. So we use method of rationalization. So we multiply numerator by the conjugate, that is 3d plus 2. Now if we simplify this, 3d plus 2 in the numerator as it is, and denominator term will be 9 times d square minus 4 into sine 2x. Now we replace d square by minus 4. So it is minus 4 into 9, that will be minus 36. Minus 4 will be minus 40. Then we apply 3d plus 2 on sine 2x. So it is equal to minus 1 by 40 6 times. So derivative of sine 2x is 2 times cos 2x. So 3 into 2 is 6. So 6 into cos 2x plus 2 times sine 2x. So this is our required value for 1 upon phi of d into sine 2x. So we use this formula, to get by equation number 2 with the particular integral. Therefore, particular integral for 1 upon phi of d into x. So our function is x into sine 2x. X into sine 2x is equal to x minus derivative of auxiliary equation upon auxiliary equation into 1 upon phi of d into sine 2x. Now we can substitute the terms. So it is x minus, since our phi of d is equal to d square plus 3d plus 2, its derivative will be, so phi dash is nothing but 2 times d plus 3. So we substitute that value 2 times d plus 3 in the numerator. Denominator term will be d square plus 3d plus 2 into value from equation number 2, minus 1 upon 40 into 6 times cos 2x plus 2 times sine 2x. So what we do, we take this bracket inside this. So it is equal to, first term will be minus x upon 40 into 6 cos 2x plus 2 times sine 2x. I hope we have taken the correct term. Fine. So x into the bracket, then this minus becomes plus. We take this 2 times d plus 3 aside upon 40 into 6 1 upon phi of d into cos 2x plus 2 times 1 upon phi of d into sine 2x, out of which we have calculated this value in equation number 2 previously. Now what is the change when your trigonometric function sine 2x is replaced by cos 2x? So we get back to the calculations once again. So here we replace sine 2x by cos. So we replace sine 2x by cos 2x. So our calculations will not be changed a lot. For trigonometric function, we replace d square by minus 4 Since after simplifying there is no term of d square, so we use method of rationalization. Here again cos 2 times x, after simplifying minus 1 by 40 can be taken outside. We operate this on this function. So here we just need to simplify this. So value for 1 upon 5 of d into cos 2x will be minus 1 upon 40 into 3 times derivative of cos 2x will be minus 6 times sin 2x plus 2 times cos 2x. Now we use this term in the second bracket. So we can substitute the values. For cos 2x, it is equal to, so particular integral is minus x upon 40 into 6 cos 2x plus 2 times sin 2x, the first term as it is, plus 2 times d plus 3 upon 40 into 6 in. So this value will be minus 6 times sin 2x plus 2 times cos 2x. Then plus 2 times, here we substitute this value as it is. Again we are forgetting that minus 1 by 40. So it is multiplied by minus 1 by 40. So this will be the first bracket. Now we take this plus 2 times b plus 3 upon 40 into 2 times, substitute that value here, minus 1 upon 40 into 6 cos 2x plus 2 times sin 2x. If we simplify this, whatever we get, that will be the required particular integral. So now we have to operate this bracket on each term here. So to simplify this, whatever we get, that will be the required particular integral. So I want you guys to find this and simplify this. So if we go for shortcut method, it will take too much time to simplify. So here it is better we go for variation of parameters method. That is the most important thing. So we have to analyze and we can figure out the exact method of solving which will be beneficial at the time of exam is just the practice. Solve examples, take your time, spend some time with the problems, go through each and every possible method of solving, then we get a better idea about it, whether to go for shortcut method or variation of parameters method or general method. So it is up to you. So this is because we have to be very careful about the precise method of solving which will save our time and get us the full score about it. So I hope you go for variation of parameters method for this type of example. Now for the fourth one, here we consider f of x is equal to x into e raised to 2x into sin 2x. So we have two shortcut method formulas. First one is e raised to ax into v and second one is x into v. So if we go for x into v formula, there are two calculations. First one is the bracket evaluation, x minus phi dash of d upon phi of d operated on 1 upon phi of d into v. Since v is combination of product of exponential function and trigonometric function, again for evaluating this part there is shortcut method formula 1 upon phi of d e raised to ax into v. So evaluation of this part, then again we have to apply 1 upon phi of d on it. So there will be a repeated formula. We have to use this at least 2 times. So it is very hectic to simplify this problem by using x into d. So it is better we skip this method of solving. Now we go for this, or variation of parameters method. So since variation of parameters method we already know, we go for the shortcut method formula e raised to ax into b. So we can consider exponential function x into sine 2x. So since our phi of d is equal to d minus 2 bracket square, if we replace d by d plus a, since a is equal to 2, this value will be d square. And it is easier to simplify double integration of x into sine 2x. Therefore, your particular integral will be, we take exponential function outside, we replace d by d plus 2 and operate it on x into sine 2x. So here e raised to 2x into 1 upon d square x into sine 2x. So 1 upon d square means we have to take the double integration. So it is equal to e raised to 2x. We take first integration. So first function as it is into integration of sine 2x is minus cos 2x upon 2 minus derivative of first function into integration. So integration of cos 2x is sine 2x upon 2 into 2. Then derivative of 1 will be 0. So we terminate that integration. So it is equal to e raised to 2x into. Now we take integration of this term first. So it is equal to. So we can take that minus 1 upon 2 outside. First function as it is into integration of second one. So integration of cos 2x will be sine 2x upon 2 minus derivative of x into integration of sine 2x will be minus cos 2x upon 2 into 2. So this is integration of first term. Then minus minus becomes plus 1 upon 4 as it is. Now we take integration of sine 2x, which is minus cos 2x upon 2. So if we simplify this, it's kind of easier, isn't it? So it is minus x into e raised to 2x into sine 2x upon 4. Then this minus minus and minus becomes minus again, e raised to 2x into cos 2x upon 4 to the 8. Next term minus e raised to 2x into cos 2x upon 4 to the 8. So if we simplify these two terms together, we get minus x e raised to 2x into sine 2x upon 4 minus e raised to 2x into cos 2x upon 4. This is your required value for particular integration. From auxiliary equation we can find complementary function as well, and general solution is yc plus yp. So in exam you are expected to solve the problem in detail and get the required solution. So I hope you have solved these problems at your own. If you have any difficulty, please review this video, and again if you have doubts then please feel free to contact me. Thank you.